Next problem, same type. So we are going to reframe the table, right? 3 varieties A, B, C of a crop are tested in a completely randomized design with 4 replications. The layout being given in the following table. The plot yields in pounds are also indicated. Analyze the experimental yield and state your conclusion. So given table, we'll see the solution. First we have to rearrange the table. So reframe the table, right? So first write treatment or varieties here, A, B, C, right? 3 varieties. And yield. So we'll check the yields, number of blocks, right? First you calculate it for A. Here also how many times A, you just check in the table. First 1, 2, 3, 4. So 4 minimum blocks, right? If it is 5, you can write 5 blocks, right? Make it one more column, whatever it is. Suppose if it is 3 only, you make it, you reduce 1 block. So 1, 2, 3. According to that number of, first you count the number of A, B, C's, right? Which one is maximum? Choose the maximum one and make it blocks, right? So first A 6, then 8, then 4, then 6, then B 9, first 9 and 6, 7 and 6, then C 5 and 8, 9, 10. So here all are equal, see, equal blocks, right? So C1 equal to C2 equal to C3 equal to 4, right? So all are equal. Total number, so how many items? 12 items. So R is equal to 3 and number of samples, each treatment, that is number of columns, all are equal here. So C1, C2, C3 equal to 4. First you define null hypothesis, there is no significant difference, right? And H1, there is a significant difference in the yields, right, of in the 3 treatments, right? So first you have to prepare the table 1 calculation for ANOVA. So make the table, write the treatment R is equal to 3 A, B, C. Then yields, then number of blocks 1, 2, 3, 4. Write the data, right, from the previous table. So 6, 8, 4, 6, 9, 6, 7, 6, 5, 8, 9, 10. Then next column, row total, right, Ri. So first row total R1, sum of the first row, that is equal to 24. Then R2, sum of the second row, that is equal to 28. Third row, sum of the third row, all the elements in third row, that is equal to 32. Next just add up this column, so you will get the grand total, sum of Ri's. So that is G. So 24 plus 28 plus 32, that is equal to 84. Next you have to find Ri square by Ci. So R1 square, R1 is 24, R1 square is 24 square, C1 is, we know, 4, all are equal, right? So 24 squared by 4, 144. Next R2 square by C2, that is 28 square by 4, 196. Next R3 square by C3, that is 32 square by 4, that is equal to 256. So sum of the all the numbers in this column, you will get summation Ri square by Ci, that is equal to 596. Then sum of squares of each data, each number, x11, x12, each number 6 square plus 8 square plus 4 square plus 6 square, right? First one. So xi square summation is equal to 152. Second row, sum of squares, right? 9 square, 6 square, 7 square, 6 square, that is equal to 202. Then third row, sum of square, that is equal to 270. Add up all the sum of square, sum of squares, right? Sum of squares, right? So yes, summation of summation, right? Squares, xij square, that is equal to 624. Next you have to find the correction factor CF, g square by n, that is equal to 84 square by 12, that is equal to 588. Next we are going to find the TSS, total sum of square. Formula SS minus CF, so that is equal to, from the table, 624 minus 588, that is equal to 36. Next, sum of squares between the sample, BSS. Formula summation RI square by CI minus CF. From the table, 596 minus 588, that is equal to 8. Then sum of squares within sample, WSS. Formula TSS minus BSS, 36 minus 8, that is equal to 28. Next, to prepare the second one, the main table, ANOVA table. So first, source of variation, there are two variation, right? BSS, and that is between and within. So between sample, within sample. Next, you write the sum of square. Between sample sum of square 8, within sample sum of square 28. Next, you write the degrees of freedom. So first one, V1, which is equal to R minus 1 between sample, right? Degrees of freedom 3 minus 1, 2. Within sample, V2 is equal to N minus R. So 12 minus 3, that is equal to 9. Next, you write the mean sum of square. Mean sum of square between sample. Formula is BSS by V1. So 8 by 2, that is equal to 4. Next, mean sum of square within sample, that is equal to WSS by V2, that is equal to 28 by 9, that is equal to 3.11. Next, you have to find the F ratio, right? Formula, here you have to check which one is the highest in the mean sum of square. MBSS is more than MWSS, because MBSS is 4, MWSS is 3.11. So whenever you are writing the F ratio, you have to write the highest number in the numerator and lowest number in the denominator. So MBSS by MWSS, that is FC, right? So that is equal to 4 by 3.11, that is equal to 1.286. So calculated value FC 1.286. Now we are going to find the tabulated value. So first to choose the degrees of freedom. Here MBSS degrees of freedom, that is V1 is first and V2 is second in that bracket, right? V1 comma V2, so that is equal to 2 comma 9. So from the table, 5% level of significance, F table, you will get tabulated value 4.26, right? Now compare the tabulated value and calculated value of F. So conclusion, here the calculated value 1.286, tabulated value more than the calculated value, that is 4.26. Therefore H0 is accepted. That is, there is no significant difference among the average yields in the three treatments. Thanks.